Here's some examples. First, what we're going to do is find, let's see, x of c. So x of c will be 1 over 2 pi, frequency is 2500, times 0.001 microfarad. So plugging that into our calculator, 2500, 0.01 microfarad times 2 pi, 1 over x. Let's see, 6.28 times 2500 times 0.001 microfarads, 1 over x, 63.69.01. Too many O's, so it must be 6369. 6369 ohms. The total, since this is a series circuit, one current path, it's going to be R minus JXC. It's a minus JXC because it's a capacitor. So this is going to be 4700 minus J, 6369 ohms. If I want to convert this into polar form, I square the 4700, I square the 6369, square root, so 6369 squared plus 4700 squared, square root is 7915 is for Z, and the angle is inverse tangent of 6369 over 4700. So I do 6369 divided by 4700 equals second function inverse tangent equals a negative 5357 degrees, and it's a negative angle again because it's minus JXC and it's a capacitor. Then if I want to find total current is going to be 10 volts over 7915 at an angle of minus 5357 degrees. This 10 volts is at its angle of 0 degrees. So 10 divided by 7915 comes out to 1.26 milliamps. And my angle is 0 minus a minus, so the current angle actually is positive. Then VR is going to be current times R, which would be 1.26 milliamps at 5357 times R is 4700 at an angle of 0 degrees. 1.26 milliamps times 4700 gives me 5.92 volts. 5.92 volts, and my angle of my resistor is 5357 degrees, and VC is going to be the current number. I'm not going to rewrite that. And XC is 6369. Now XC is at minus 90. So I take 1.26 milliamps, multiply that by 6369 to get 8.02 volts, and the angle is going to be 5357 minus 90, so you get a negative angle on this, minus 3643 degrees. And here you can see the power triangle or the impedance triangle, right? We had that, we got this, and there's our angle, 53 degrees. Yeah, 53 degrees, and it's a negative. Okay, the next one, RL. First thing we do is find XL. XL is 2 pi frequency times the inductance. 2 pi times 10 kilohertz times 15 millihenries, which is equal to 6.28 times 10,000 times 15 milli, comes out to 942. So the impedance is going to be R plus JXL, so it's 1K or 1000 plus J 942, converting that to polar form. So it's 1000 squared plus 942 squared is equal to 1373.8, and the angle is going to be inverse tangent of 942 over 1000, and this angle comes out positive. So this is going to be 942 divided by 1000, second function inverse tangent, 43.28 degrees. Okay, and there's our impedance triangle. Resistance, the Z, there's XL, 942, and there's our angle. XC, again, 1 over 2 pi times 2000 for frequency times 0.047 micro comes out to, let's see, 6.28 times 2000 times 0.047 micro, 1 over x is 1693.9 ohms. So the impedance is going to be 27 minus J, 1693. Converting that to impedance, 2.7K squared and 1693.9 squared. So I get 2700 squared plus 1693 squared, square root 3186.8 at an angle of inverse tangent of 1693 over 2700. So it's 1693 divided by 2700. Second function inverse tangent is 32 degrees. It's a negative because of the capacitor. To find current, again, is 10 volts over 3186.8. So that gives me 10 divided by 3186.8, 3.13 milliamps. This time I won't use the angles all the way through. VR is going to be 2700 times 3.13, and VC will be 2700 times the 1693. 2700 times, oh, I did that wrong, 3.1, not this one, milliamps. It goes 8.451 volts. And this is not 2700, it's current times 3.13 milliamps. So it's 3.13 milliamps times 1693 is 5.299 volts for that one. And here we have our triangle again, all of the values indicated. This is showing it times the current, gives you those current values. Let's see, 529,845. I believe that's what we had. Yeah, 529,845, and the source is 10. Now, as the frequency of a RC circuit decreases and Z decreases, each frequency can be visualized as a different impedance triangle. So this is just showing as frequency goes up, this is what happens. Okay, I think that's all. I wanted to go to slide 30 next. Let me see, wait a minute. Okay, RLC circuits. Let's first find X of C. Same formula, 2 pi FC. So putting in 6.28 times 50K times 0.01 microfarads, 1 over X, is 318.47. XL is just 2 pi F times L. So it's 6.28 times 50K times 2 milli is 628. So XL is larger, so the impedance is R plus JXL minus JXC. and it becomes 820 minus J628, or plus J628 minus 318.47. So Z is going to be 820, and you combine the 628 with the 318, 309.53. And then after this point, all the math is the same. You convert to polar, so it's 820 squared plus 309 squared. So you get 820 squared plus 309 squared, square root is 876. Then current will be equal to 5 volts divided by 876. Comes out to 5.7 milliamps. And then VR is current times R. VC is current times XC. And VL is current times XL. So this is the 318 number. This is the 628 number, and the currents are the 517. And here we have the triangle. So our angle is inverse tangent of 309 over 820. So I got 309 divided by 820. Second function inverse tangent is 20.6 degrees. And that's what it showed on the next slide, 8 degrees. Alright, here is calculating the voltages. So if you take those current numbers and multiply them through, that's what you'll come out with. Series resonance circuit. Here, the impedance is equal to resistance at resonance, and current is a maximum at resonance. Because resistance is small, you get a maximum current. So the output voltage or the output current follows the peak voltage that way. Now, so this is a band pass filter because this is passing signals, versus this is a band stop filter. Here you can see that since at impedance, this is going to be equal to each other. The XL and the XC equal each other. So basically their net reactance is 0. So there's no output voltage there. So that's not letting any frequencies pass. So that's a band stop filter.